Hi, my name is Myat Phyu, and in this video, I will be presenting my project on image classification using convolutional neural network CNNs for short. Firstly, I will rerun this design code to achieve the similar outcomes. I will run this code one by one. So let's wait for a moment. Is the public image dataset from Kaggle that contains different categories of animals stored in separate folders. In this presentation, I will walk you through how I imported the dataset, pre-processed it, built and trained the CNN model, and finally evaluated its performance. By the end of this video, you will see how my model can classify images into their correct category using deep learning. So let's start with the first section, that is importing libraries and loading dataset. Here, I have imported the essential Python libraries like TensorFlow, NumPy, Matplotlib library, and some utilities from Keras for data pre-processing and model creation. Next, I imported the dataset using image dataset from directory. This method automatically reads all the images from the dataset folders, assigns label based on the folder names, and creates training and testing dataset. For example, if I am working on the animal dataset, the folder names like cats, dogs, snakes become my class label. So after loading the dataset, I perform several pre-processing steps. First, I set the image size to 64 by 64 pixels and a best size of 32. And then I manually split the dataset into 80% of training and 20% of testing. To make the model perform better, I normalize the images so that all pixel values fall between 0 and 1. This step is super important because it helps the neural network train faster and more efficiently. And then I visualize the training data shape and training label shape, test data shape, and test label shape. Next, I move on to the most important part, building the convolutional neural network model. I started with a Conv2D layer with 32 filters and 3 by 3 corner activated by ReLU function. This layer extracts low-level features such as edges and color. And the next layer is mass pooling 2D layer that reduces spatial dimensions and computation. I added another Conv2D layer with 64 filter followed by another mass pooling 2D. This combination has captured more complex pattern. And then I added the flattened layer, which converts the 2D feature mass into a 1D vector for the dense layer. After that, I included a dense layer with 128 neurons and a ReLU activation function and to learn the features. To avoid overfitting, I also added a dropout layer with a rate of 0.3. Finally, here are the hidden layers. Finally, I use an output layer with a softmax activation function that outputs probabilities for each class. So after defining the model, I combine it using the agent optimizer because it automatically adjusts the learning rate, and I also use categorical cross entropy as the loss function since this is a multi-class classification test. And for metric, I use accuracy to monitor how well the model performs during training. And then I train the model using the fig function. You can see that I pass the train data. I pass the train data and validation data along with the number of epochs. During training, you can observe the accuracy improving gradually with each epoch, while the loss decreases, showing that the model is learning the underlying patterns in the data. And then I also visualize the training and validation accuracy, and the next one is training and validation loss. Once the training was complete, I evaluated the model by making predictions on a few test images. Here I am using the model.predict function on the first three images from the test dataset. The output shows the prediction probabilities for each class. This number represents how confident the model is about each possible category. Next, I use unmatched function to get the index of the highest probability, which tells me the predicted class for each image. Finally, I map those predicted indices back to the actual class name. For example, dog, cat, or snake, so we can clearly see what the model thinks each image is. This helps verify whether the model is correctly identifying the animal based on what it learned during training. Here, I am evaluating the model on the full test set. I use model.predict function to get the predictions and also np.argmax function to find the predicted class label. And then I compare the true labels and generate a confusion matrix. So this matrix shows how well the model classifies each category where it made mistake. Next, I visualize one of the test images to see the model prediction. Here, I am displaying the second test image with Matplotlib library and adding the predicted animal label as the title. This helps me visually confirm if the model prediction matches the accurate image. So let's scroll up. As you can see here, the second image is cat. So the visualization also shows the cat image. So now I will try with that test image. So I will change here two and also two. Let's run this code. It will show the snake image. So my code is running properly. Now I will try with instead of animal dataset, I will try with the flowers dataset that I have already downloaded in my local machine. So here I will change the predicted, that is flower. Now I will rerun the code one by one. Okay. So let's wait for a moment. And my flower dataset contains 5 types of flower, that is daisy, dandelion, rose, sunflower, and tulip. As you can see, it is also working properly for the flowers dataset. This is that image dandelion. So now I will try with another image, that is sunflower. That is again test image. So this is the and this go. Here, as you can see, this is the sunflower. So in conclusion, through this implementation, I learned how CNNs can automatically extract important visual features from the images without manual feature engineering. I also realized how important pre-processing, normalization, and dropout regularization are for achieving good model performance. Overall, my model successfully classified images with strong accuracy, proving that deep learning can be very effective in solving image recognition. So that's all for my presentation. Thank you.